Hi friends, welcome to all. In this video, we are going to see the packet tracer activity configuring extended ACLs scenario 1. We will go through the objectives. In part 1, configure, apply and verify an extended numbered ACL. In part 2, configure, apply and verify an extended named ACL. Also, we will go through the background. Two employees need access to services provided by the server. PC1 only needs FTP access while PC2 only needs web access. Both computers are able to ping the server but not each other. Coming to the topology, here we can see the PCs and server. So here, according to our background scenario, this PC1 only needs FTP from this FTP access from the server, and for this PC2 needs web access from this server. Also, both PCs, that is PC1 and PC2, should able to ping to this server but not each other. Coming to part 1, configure, apply and verify an extended numbered ACL. In that step 1, configure an ACL to permit FTP and ICMP. From global configuration mode on R1, enter the following command to determine the first valid number for an extended access list. So here we are going to give access list space then a question mark. Coming to the router R1, enable configure terminal. Here we are going to give access list and we are going to give the question mark, and here we can see IP standard access list is from 1 to 99 and IP extended access list from 100 to 199. Coming to B, add 100 to the command followed by a question mark. So we are going to use this IP extended access list using the first number 100, right? Check that 100 and then question mark, and here we can see the three options: deny, permit and remark. Coming to C, to permit FTP traffic, enter permit followed by a question mark. Right here we are going to use this permit specify packets to forward, right? Permit, then we are going to give question mark, and here we can see the commands. Coming to D, this ACL permits FTP and ICMP. ICMP is listed above. Yes, here we can see that ICMP, but FTP is not, because FTP uses TCP. So here we can see that TCP, yes, transmission control protocol. So you enter TCP to further refine the ACL help. Here we are going to give a TCP, then question mark. Here we can see ABCD source address, or we can give any command, any source host. Also we can see host, a single source host. Coming to E, notice that we could filter just for PC1 by using the host keyword, or we could allow any host. In this case, any device is allowed that has an address belonging to the 172.22.34.64/27 network. Enter the network address followed by a question mark. Yes, we are going to give this address and then question mark. Coming to the topology, here we can see the network 172.22.34.64 will be able to access the FTP from this server. So here we are going to give the network address 172.22.34.64, then question mark. Here we can see we have to give the source wildcard bits. Coming to F, calculate the wildcard mask determining the binary opposite of a subnet to mask. Yes, here we can see they given the binary of subnet to mask, and here we can see the opposite of subnet to mask, so that we get these wildcard bits. Coming to G, enter the wildcard mask followed by a question mark. Right, we will do that. So here we are going to give a 0.0.0.31 and a space question mark. Here we can see the commands. Coming to H, configure the destination address. In this scenario, we are filtering traffic for a single destination. Exactly, that's for the server. So enter the host keyword followed by the server's IP address. Yes, so here we can see the destination server. So we are going to give this host IP address. Here we can see that host, then 172.22.34.62, the IP address of our server. Here we are going to give that host, then we are going to give the address, so that server address. Yes, here it is. Then we are going to give the question mark. Now we will come to I. Notice that one of the options is CR, that is carriage return. Here we can see that, right? So in other words, you can press enter and the statement would permit all TCP traffic, right? So however, we are only permitting FTP traffic. Therefore, enter the EQ keyword, yes, followed by a question mark to display the available options. Then enter FTP and press enter. Coming to the configuration, here we are going to give this EQ match only packets on a given port number, right? Now we are going to give a question mark again, and here we can see the protocols: FTP, POP3, SMTP, Telnet, and WWW. So here we are going to give FTP, and now we are going to press enter. Coming to J, create a second access list statement to permit ICMP, like ping traffic from PC1 to server. Note that the access list number remains the same and a specific type of ICMP traffic does not need to be specified. So here we can see that access list 100 permit ICMP 172.22.34.64 and the wildcard bits 0.0.0.31 and the host 172.22.34.62. That means from this network, all the devices will be able to ping to this web server. Here we are going to give that access list, same number, that is 100. Here we are going to give a permit ICMP, and now we are going to specify the network address, that is 172.22.34.64, and now we have to specify the wildcard bits, that is 0.0.0.31. Now we are going to specify the single host, destination host, and its address, that is 172.22.34.62. Coming to K, all other traffic is denied by default. Yes, so this network will be only able to ping to this web server and all other traffic will be denied. Coming to step 2, apply the ACL on the correct interface to filter traffic. From R1's perspective, the traffic that ACL 100 applies to is inbound from the network connected to Gigabit Ethernet 0/0 interface. Enter interface configuration mode and apply the ACL. So we have to go to this interface Gigabit Ethernet 0/0 and we have to give inbound. Here we can see the interface Gigabit Ethernet 0/0 on this device R1. Coming to R1, now we have to go to the interface Gigabit Ethernet 0/0, and here we are going to give IP access group, the number is 100, and inbound. Coming to step 3, verify the ACL implementation. Ping from PC1 to server. If the pings are unsuccessful, verify the IP addresses before continuing, right? So we will ping from this PC1 to this server. Ping to our server. Yes, we are getting the reply. Next is FTP from PC1 to server. The username and password are both Cisco. Right, we are going to give this command FTP and the server address. Then we have to exit the FTP service of the server using quit. Right, we will come to PC1 command prompt. Here we are going to give FTP and our server address, that is 172.22.34.62. Username is Cisco, password is also Cisco. Yes, so we able to access FTP, and now we will quit from our FTP server. Right, coming to D, ping from PC1 to PC2. The destination host should be unreachable because the traffic was not explicitly permitted. Exactly. So for this PC1 and PC2 is not going to ping each other. So we are going to get the IP address of PC2. Coming to PC1 command prompt, we are going to ping to PC2. Here is the address, and here we can see destination host unreachable. Now we will come to part 2, configure, apply and verify an extended named ACL. In that step 1, configure an ACL to permit HTTP access and ICMP. So coming to A, named ACLs start with the IP keyword. Right, from global configuration mode of R1, enter the following command followed by a question mark. IP access list, then question mark. So we are going to get this extended and standard. Right, we will check that. Coming to our router R1, we are going to exit from the interface mode, and here we are going to give IP access list and question mark. Here we can see the options extended and standard. Coming to B, you can configure named standard and extended ACLs. This access list filters both source and destination IP addresses. Therefore, it must be extended. Enter HTTP underscore only as the name. For packet tracer scoring, the name is case sensitive. Right, so we have to give in caps only. This is for scoring in this packet tracer activity. Coming to the configuration, here we are going to give extended and HTTP underscore only. Coming to C, the prompt changes. You are now in extended named ACL configuration mode. All devices on the PC2 LAN need TCP access. Enter the network address followed by a question mark. Here we can see that permit TCP 172.22.34.96, and we are going to give a question mark. Here we are going to permit this network to access the HTTP from this server. So here we are going to give a permit. We are going to permit the TCP, and here we are going to go, we have to specify the address, source address, then question mark, source wildcard bits. Coming to D, an alternative way to calculate a wildcard is to subtract the subnet mask from 255.255.255.255. Yes, here we can see that. So here we get the wildcard bits 0.0.0.15. So we are going to give that here. Coming to our configuration 0.0.0.15, and then we will put question mark, and here we can see the number of options. Coming to E, finish the statement by specifying the server address as you did in part 1 and filtering www traffic. So here we are going to give this EQ and filtering with the www traffic. Coming to our configuration, now we are going to give here a host, a single destination host. Then we are going to specify the server address here, that is 172.22.34.62. Yes, and now here we can see we are going to give a match only packets. For that we are going to give a EQ. Then for the HTTP we have to give www. Then we are going to press enter. Coming to F, create a second access list statement to permit ICMP like ping traffic from PC2 to server. Note the prompt remains the same and a specific type of ICMP traffic does not need to be specified. So this is the command we have to give, permit ICMP. Then we have to specify the network and it's a wildcard mask, then the destination host and its IP address. Coming to the configuration on R1, here we are going to give a permit ICMP. Then we have to give the source address, that is 172.22.34.96. and now we have to specify the wildcard bits, that is 0.0.0.15. Now we have to give a single destination host, so we have to give a host, then destination address, that is 172.22.34.62. this is the address of our server. Coming to G, all other traffic is denied by default. Exit out of extended named ACL configuration mode. Right, so press Ctrl Z. Now we will come to step 2. Apply the ACL on the correct interface to filter traffic. From R1's perspective, the traffic that access list HTTP_only applies to it is inbound from the network connected to Gigabit Ethernet 0/1 interface. Enter the interface configuration mode and apply the ACL. Coming to topology, here we can see the interface Gigabit Ethernet 0/1, and we are going to apply this ACL on this interface. Coming to the configuration, configure terminal, we have to go to the interface Gigabit Ethernet 0/1, and we are going to give a IP access group, and we have to specify the access list name we created, that is HTTP_only, and we have to specify the inbound, so that's in. Coming to our final step, verify the ACL implementation. Ping from PC2 to the server. If the ping's unsuccessful, verify the IP addresses before continuing. Right. So from PC2 to the server, the ping should succeed. Coming to PC2 command prompt, we are going to ping to our server. Here is the address. Yes, we are getting the replay. Coming to B, FTP from PC2 to server, the connection should fail. Right, we are going to access FTP from this PC2. So we are going to give FTP and our server address, and here we can see trying to connect. Here we can see disconnecting from FTP server timed out. And coming to C, open the web browser on PC2 and enter the IP address of server as the URL. The connection should be successful. Coming to PC2 web browser, here we are going to give the IP address of our server. Yes, we are getting the web page. Well, that's all in this packet tracer activity configuring extended ACLs, and here we can see the completion status 100 out of 100. Friends, if you have any doubt regarding this packet tracer activity, please comment below. Also, if you like my video, give a thumb and don't forget to subscribe the channel. so that you will get latest uploading video info into our Gmail. Thank you.